Okay, so I guess we get started. Good morning. My name is Michael Lagalli. I work for Oracle in the Java Platform Group, and I'm going to present to you JAX-RS-ME. JAX-RS-ME is a new API for RESTful web clients on Java ME. We have been working on this as an internal project for several, well, actually since the beginning of the year. And we have developed an API that follows RESTful patterns on Java ME clients. We have a client API which is based on, how can I stop this? Which is based on JSR 339 to consume web services with REST concepts from Java. We provide a higher level abstraction than HTTP to access web resources, to transmit arbitrary MIME types between a client and a server, and to transmit Java objects, actually. We encapsulate web concepts such as a target, a path. We do invocations, we have a request. We talk about responses, entities, and headers. So this is the structure of the presentation. First of all, I'm going to explain to you why REST is important. Maybe just for my insight, who of you has been working on REST APIs or using REST? Okay. So I'm going, probably that's not new for you why REST is important and what it is. But anyway, I'm going to give a little bit of motivation on that. Then I talk about the JAX-RS-ME API, specifically about the architecture, the principles, and the model. And also I'm going to show on some examples how JAX-RS-ME can be used and the beauty of the API and where it really helps us to go to a higher level abstraction than just talking in plain HTTP packets. And then a little bit of under the hood look, where I'm going to show how it works and what the concepts and the extensibility is. So first of all, very high level, what is REST? So it's an acronym for Representational State Transfer, which is a model for distributed services in service-oriented architectures. It's one of the structures that's prevalent on the internet. And basically, the principle is that we have a system of distributed, reusable, and decoupled web services with a couple of nice features like scalability and having a common and simple protocol that works across all different devices and firewalls. There are earlier technologies, for example, a distributed computing environment, DCE, then Corba, Java RMI, and also SOAP-based web services. And typically when we talk about REST, people think REST over HTTP, but it doesn't have to be over HTTP. You can do it also across and over other protocols. Basically, every web service is REST. So even a simple web server, which just delivers web pages, static web pages without anything beyond that, is a RESTful server. Why is REST important? So there's a nice page on the internet which is called programmableweb.com, which has a directory of RESTful web services. It has a directory of web servers in general, but you can filter for categories and for protocols and styles. And if you go there, I did that 1 month ago or so, there had been more than 4,400 REST services with all the who's who in the internet in the list. So you can, it's a little bit small, but you can read Twitter and Flickr and Amazon and Facebook and eBay and Last.fm and Delicious and Yahoo and Google Ajax Search and Yahoo again and Foursquare. So basically everything is REST. And this has by far outweighed the SOAP services, for example. So there's only 1,350 SOAP-based web services, 150 XML RPCs. And probably the figures by now have changed again. REST is basically a collection of principles of how to do conversation between different machines. So first of all, the underlying concept is every addressable object is called a resource. So a service and an object is a resource, and each of these items has a URI. So you have a unique way of identifying an object or a service. So we have a way of identifying an object. And then we have a couple of simple methods, and these are just the HTTP methods, and basically you just need 4 of them. You need get, put, post, and delete to talk to every resource that's on the net. It's representation oriented, and a single resource on any server can have different external representations. So on the server you may have something which is implemented in, let's say, in C++, or it could be Java EE, or it could be any other way of implementing a web service. And the external representation could be just a common exchange format like HTML, XML, JSON, or others. We have stateless communication. So that means that you can easily scale, you can deploy a service across different servers. You don't need to have a session context, and every state is just contained in the request itself. And then there's another acronym, hypermedia, as the engine of the application state. So that's a complicated acronym, but the idea is pretty simple. So basically, we're using hypermedia, which means linked documents, and the hyperlinks actually represent the state transitions between the different application states. So that was about REST in general. Now we come to JAX-RS-ME. So we have not been reinventing the world, but we have been taking a subset of the new JSR 339, which is currently just going into public review. So it's an enterprise edition JSR. And we have been tailoring it down to run on CLDC. JSR 339 is a JAX-RS 2.0 client and server API. And since we're on the client only, we have only been using the client API. It's a higher level API framework, so it is above HTTP, and it enables transmitting of arbitrary Java types. The API is completely agnostic from the external representation, so the API does not limit you to use JSON or to use XML or anything else. And the client and the server negotiate over HTTP content negotiation on a common, understandable set of representations. So basically the client tells the server and asks the server what it can provide, and tells the server the capabilities it can support, and then they agree automatically on what they do and what language they speak. And we are encapsulating REST and web concepts like URI and path, and we had that before. A high-level architecture picture. So underneath we just have CLDC, and on top of that we have the JAX-RS-ME API and specification, which consists of a provider framework that allows to configure and to extend and to modify the behavior of the API. We're coming to that in more detail later on. And we have configurable types. So we have a client, we have a web target, which is a pointer to the server. We have an invocation, which is basically a call to a method on the server. And on top of that, we have an application. We can have a midlet, we can have an EMlet, which is the embedded application equivalent to a midlet. We can also have a simple plain CLDC main, so we don't need to have anything from a higher profile. If we have a higher profile like midp or IMP, or what is now called the embedded profile, the API gets extended, and that's a bit hard to draw in an architecture diagram. But in this case, we can use the service loader to also plug in additional things into the provider framework, just using the concepts that we have here. So basically, we can use shared libraries to extend what the behavior of the JAX-RS-ME API would be. And if you look at the picture again, we have the providers. And providers is a very generic concept here. So a provider is basically the mapping of a protocol into the framework. So we can have, as we see in the lower layer, we have the provider framework, which has filters, which has interceptors or entity providers. And these providers can be extended by platform providers, so by plugins as a shared library, if we have MIP or IMP, or they can also be supplied by the application. So if an application wants to speak a very exotic language or needs to support a very specific protocol, like CoAP, for example, this could be provided as part of the application, or it could be provided as part of a shared library. Why is JAX-RS useful on Java ME, on a client? So first of all, it's a lightweight API. It's simple to use, and it's powerful to use all REST-based web services from a feature phone and from a small embedded device. It's based on HTTP, which is, it's a small API, as I said before. It has limited footprint. It has a powerful extensible framework for serialization and deserialization of Java types. So basically you can put and get Java objects over HTTP, and the platform takes care over the serialization and the deserialization. And so you basically invoke a method with a Java object on a web server, and you get a Java object back. JAX-RS defines out-of-the-box support for simple types, so it supports byte arrays, strings, and input streams, but it's as powerful as to support generics and array types and arbitrary collections of objects. It supports a fluent API style. I'm going to talk about that a little bit later. So it allows a very expressive way of chaining method calls into a combined statement which has a lot of expressiveness in a single line. The API hides protocol and content representation details from the application. So, a small animation on how it works. We have the client on the left side with the JAX-RS framework, and the server on the right side where we have the target. So some kind of resource on the web, and we want to use it and talk from the client to the server. So we have a Java object, O1, and we are invoking something on the target with O1 as a parameter. And O2 is the return object of this invocation. So we just do an HTTP request to the target, and we get an external representation of O1 in a form that the server understands. So it could be XML, it could be JSON, it could be binary, it could be anything. Then on the target, the server decodes or demarshals the object. It has the object O1 again. It can do something with it. It processes it. And at some point of time, it has a return object, O2. And this object is returned over the network again as an HTTP response with another external representation of O2. And then on the client side, we have the object O2. And the external representation is not seen in the Java API on the client side. I'm going to show you a little bit more how this works in the examples. So that's a simple example of receiving an instance of a user-defined class via JSON. And first of all, we have to create a client. This is a little bit of boilerplate code. So we create a client instance using the client factory. It's very faint. I don't. It's hard to see. Okay, so we're here. Then we create an instance of a web target. So we just talk to the server http://example.com, and we address a remote resource on this server. So the blue marked methods are JAX-RS methods. So first of all, we create a target. Then on the target, we address a path. And this is a web resource for JSON, so it could be just a path segment for a resource where we know that it is capable of returning a JSON response. Then we create a request, and we tell the request that we want to get the JSON type. So media type is also defined by JAX-RS. And we are building a GET. And this basically is our invocation. And then we just invoke this method. And here we get a response. And we read the entity into a user class. And then we have the instance. That looks pretty simple, I would say. And here in this example, we see all the important concepts. We see the target, we see the path, we see the request, we see the method, we see the invocation, and we see reading the result. Now let's make this a little bit more simple. So now we convert this into Fluent style. It's the same example. So boilerplate code again, client factory new client API. We get the response by invoking the get method, and now we just do it in a single line. So we do client.target with the URL, then we add a path with the web resource. So that's the identification of the remote object. We do a request on this web resource, and we expect a response in the media type JSON. We build a get on that, and we invoke it. And then we get the user class object again. So now we have been folding this set of 5, 6 different programming lines into a single line, and this is what is called Fluent style. So it's a chaining of method calls, and this is more expressive, and we have more compact source code. So you can do a whole invocation on a single line. If we look briefly again into the previous one, it's a couple of lines longer, and now we have been folding 4 lines into a single line. That's all, no magic. A second example. So say we wanted to receive something from a server, but we don't know exactly whether the server can support JSON, or it might also just only support XML as an external representation. So in this case, we create a web target again, as we did, and on the target line, we now have basically a web resource which could be just the same as we had it before. And the only difference here is on the invocation that we, on the request line, query both media types. So we ask for JSON or for XML, and we build a get here, and we invoke the method, and we get a response object, and read the object again. Okay, that was receiving of an object, and now we are sending something. So let's assume we have a user class object and an instance UCO. We do what we have already been doing before, so we create a target with a path, and now we create an entity for the user class instance. And that's a mistake here. This should be not JSON but XML. So we create an entity for the user class instance, and we encode it in XML. And now we just call the method again. So we build a post with the entity as a parameter. So we have a kind of wrapped encoding of the user class object, and we invoke the method here. And then we check the response status, and if the response status is not okay, then we do some error handling. And we don't care about HTTP headers, we don't care about XML encoding. Everything is just happening behind the scenes in the framework. A couple of observations here. So the method invocation is completely independent from the external representation. And there are only minimum changes required if you want to adapt to other representations. All details of the parsing and encoding process are separated from the application. So we have not seen any XML parser or JSON parser in these examples. An application just invokes methods on web resources and passes Java objects as parameters. And we get return objects, which are also Java objects. And this works for simple objects, it works for arrays, it works for generic types. And we can use Fluent style to chain methods into a single statement or a single line. So, you've seen the magic, now you're certainly interested how it works. The API defines a client-side framework, and you can use it to construct object references to remote objects. That's the web target, we have seen that before. We can create server requests, we can invoke requests on the server, and we can process server responses. And the framework supports converting between Java and external representation formats and has a common interface and a common way of defining these kind of wrappers and converters. Marshalling, unmarshalling is the type that is used in Corba. The JAX-RS operations are HTTP methods. So get, put, post, and delete is used here. Get is equivalent to reading an object, put is writing an object, post is adding an object, and delete is delete. So how do we speak a common language between the client and server? Since we have different capabilities, and the external representation format depends very much on the common capabilities. So you have a server which can handle several media types, you have a client which can only handle a subset of that, and they need to indicate and communicate somehow the capabilities. And there's this HTTP content negotiation where the client tells the server that it can handle the following MIME types. For example, it can only handle text responses or text HTML or application XML or application JSON as types. Then it can also indicate language encodings in the locally, and you can imagine doing additional encoding of the actual protocol like gzip compression or deflation. The client maps the Java objects to requests and responses and processes the HTTP messages. And the mapping happens via an extensible framework of what is called here providers. And there's a couple of configurable types to modify the behavior of the framework. We have basically 4 configurable types. We have a client, where you can hook in different providers. We have a web target. We have an invocation builder, which is creating what's actually happening in the invocation. So it puts together the different segments and parameters that go into the invocation. And then we have the invocation by itself. And per configurable type, the providers and other properties can be individually set. So several provider types. We have entity providers, and there are basically 2 interfaces that can be implemented. We have a message body reader, we have a message body writer, and they define a mapping between the external representation and the Java objects. And here if we just think briefly how an HTTP message looks like, so you have a header and you have a body, and these providers map the body of the message into a Java object. So we see a little bit more in detail how this works. Then we have another extension point. So first of all, we have the marshalling, the unmarshalling, which can be plugged in. Then we have the entity interceptors, so we can wrap around the read and write methods of the providers. As I said before, we have something to read and to write from the message body, and you can put a wrapper around that. And this is called entity interceptor and can be also extended here. So for example, you could extend all providers, all readers and writers with a common compression scheme. And last, we have filters, which define an extension point before and after a request is dispatched and to and from the transport layer. So there are different layers here. And before a message gets actually sent into the protocol, the filters are called. So you could also use the filters to convert to a completely different protocol and not use HTTP, but use something else, like CoAP, for example. These filters can be used for other purposes as well, like for having a common logging facility where you have all your messages being just logged to some kind of debug protocol. The extension of the framework works because the providers are looked up and used dynamically. So they are determined dynamically at runtime based on what you actually get in the protocol response, based on the MIME type and the Java type. And this is extensible, so if no reader for a specific type can be found. So you try to, try to receive some kind of second version of a user class. And then if no reader is in the system for this specific subclass, there's a mechanism to find the reader and use the reader for the nearest supertype. So it's a common mechanism to always use the best possible matching reader to read the response and to process the message. And there's also some kind of binding precedence on the filters and interceptors, so there's a guaranteed sequence of how these filters and interceptors are executed. So assume you have multiple filters, you can have just a sequence of how they are applied. Assume you wanted to do logging and conversion to a different protocol, and you wanted to do gzip encoding. You can ensure via binding precedence which one of these filters happens and is applied. How can new providers be deployed? So, as I said before, additional providers can be created to adapt to other transport formats or new content types, so basically to extend the framework. And also a single provider can be used for multiple roles. So you can create a message body reader to handle multiple Java types. So let's say you have 3 user classes and you wanted to serialize them to JSON, then it doesn't mean that you have to create 3 different instances of a reader for that. You just create one and you do some type introspection and find out which type you're going to use, and the reader then just can process them accordingly. Providers can be included in the platform. So when JAX-RS is deployed, you have a couple of standard providers that are guaranteed to be in all platforms. These are very simple things like string or byte array providers. We can deploy them as a service if the platform supports the service loader, so it's able to handle shared libraries, and they can be bundled with the application, as we have seen in the architecture picture before. And that's the common and flexible extension mechanism. So, an example. The message body reader interface. And this is used for converting an HTTP message body to a Java objects. And you only have to implement 2 methods. So that's pseudocode without all the details of the parameter names, but basically it looks like that. You have to implement 2 interfaces when you want to create a new message body reader. You have a Boolean method called isReadable, which checks whether the implementation can read a Java type from the media type that is specified here. So you can call its readable byte array with a media type of JSON. Or you can call its readable of Java AWT image, for example. Well, that doesn't exist in CLDC. Let's pick something else. Is readable for string array, and the media type would be application XML. So you would return true if the writer can be used to convert from a media type to the Java type. And then the framework itself calls the read from. So all this is hidden from the actual application. We are currently under the hood. We are creating custom and extended providers and extend the interface. So the read from method is simple as well. So we have the Java type and the media type once again. And then we have an input stream and we have HTTP headers, which can also be used from the provider implementation to do additional processing. And this method, this read from, returns an instance of the Java type that's on the parameter line. So it reads an input stream and has a parser for the appropriate media type format. So as a practical example, for example, if you have a JSON reader here, you would understand the media type application JSON, and you would have a JSON parser as the implementation here. Or if you have a media type application XML, you would have an XML parser and read just an XML block from the HTTP packet and convert it to a Java type, which you then return as the return value of the read from. And that's pretty flexible. Message body writer is also not very complicated. So we have an isWritable, which is very similar to the isReadable. Once again, checking whether this provider can be used to convert from the media type to Java type. Sorry, from the Java type to the media type. Now we are writing, so we are doing just the opposite way. We return true if the writer can be used to convert, and this is just used internally from the framework to determine which of the providers can be used for a specific invocation. And this is happening completely dynamically, as I said before. There's also a new method which is called getSize to find out what the length of the serialized form of the Java type would be. This is important if you want to segment things or if you want to ensure that things fit into a certain payload size, just to do potentially to snipping a message into different segments. And then we have the write to, which takes an instance of the Java object and writes it to the output stream in the appropriate media type. And I gave the example of having a provider for only one media type, but you could also imagine to have a common provider which can write a Java object class into JSON or XML. So it could support both. You just would check on the media type, and depending on what you have, what you want to create, you can use the same writer, and it would just use a different way to externalize the media type, the Java type into a media type. Okay, so we touched the readers and writers. The filters and interceptors basically work in a similar way. We don't go down because that would blow the scope of the presentation. The interesting thing is you can set you can have various extension points. So you not only have and you can set them at individual extension points. So you can set the providers on the configuration, and you can have multiple configurations in the same runtime. So you could imagine having even two different protocol configurations that you would use And one would be using HTML and the other would be, for example, co-op. The readers and writers can handle arbitrary Java types, and you can use them to adapt for new payloads and new formats. The filters and interceptors can be used to do additional processing, compressing, or mapping to other protocols. We talked briefly about standard entity providers. So what comes out of the box? We have byte arrays that can be transfer encoded. We have strings, we have input streams, and we have readers. And then a couple of, the multi-valued map and the streaming output with a couple of constraints. And this basically is the API, a very small framework to do invocations, to flexibly construct method calls and to return objects, to encode and decode Java objects. We have been defining a clean subset of JSR 339 with no additional classes and methods. So everything that you code against this API should run on JSR 339. It's suitable for resource-constrained phones and small embedded devices. So we have done a reference implementation, which has a footprint of something like 200K. And we matched the capabilities of the JAVA-ME platform, which was quite a challenge in some areas because JAX-RS-ME has some, well, a lot of concepts which don't exist on JAVA-ME. The applications can be written using a subset of the familiar REST API from JSR 339. So if you want to go on the mobile platform or on an embedded platform, and if you know JSR 339, you're on familiar grounds. There have been a couple of challenges on JAVA-ME. For example, we don't have runtime annotations in JAVA-ME. We just have the compile time annotations. And so we cannot do annotation-based discovery of providers. We need to have explicit registration from the application or from the service here. That's an implementation detail. It doesn't limit the what you can actually do with the API. There's also no out-of-the-box platform support for JAX-B in JAVA-ME. So we don't have an automatically way of parsing XML here. But that's something the application or the provider could provide. And this is something like an outlook here. We have been recently looking into using a common REST API for also embedded servers where maybe not HTTP is used, but some other protocols. And I mentioned it before, co-op is defined in etc, and it's used for M2M communication. And there is a mapping as part of the co-op spec between co-op protocol. So it's a binary protocol, but it follows the same scheme as HTTP. So you find also similar methods like get, put, post, and delete. And you have binary representations here. And we are currently investigating a mapping and an extension, or maybe just a use of this API for also co-op protocol. And the current view, and we are still investigating, is whether a mapping via filters and interceptors can handle the whole thing. So we have a pretty abstract API, which does not really expose a lot of HTTP. There is one class where we have access to the HTTP headers, but they would not have to be HTTP. So it's basically just a header class for additional attributes that get sent in a request. Okay, but this is work in progress, and we are continuing on that. So some more information. There is the JSR 339, which, as I said before, is currently a public specification done by colleagues of mine from Oracle. There's the Jersey implementation. That's a Java EE JAX-RS implementation with a lot of documentation on jersey.java.net. There's a very useful book written by Bill Burke on RESTful Java, with JAX-RS, which explains in an excellent way all the concepts. So I can strongly recommend that. And if you want to know additional things about what we do here or what we have, I'm here. I'm here for questions. I have business cards. I have an email address. So I'll be happy to answer everything in addition that goes beyond the slides. All this would not have been possible with the help of many people. So many thanks to the spec leads of JSR 339. This would not be possible without them. And also many people at Oracle who helped on contributions, support, feedback, and discussions. Okay, that's the safe harbor statement. So basically everything I just told you in the last 45 minutes has been untrue, completely lies. And now I'm available for questions.
So I understand that JAX-RS is added to the web services specification. It's been there, I think, for the last couple of years now, I guess. What do you think? What do you think the tools are mature enough to adapt JAX-RS?
So the question was how I think tools
like tooling, like Eclipse, all the development tools, are they mature enough to integrate with the JAX-RS?
Well, not sure whether I understand the question when you say to adapt to that. Basically, you just use Eclipse or.
How's the tooling support available? Is what my question is.
Okay. So basically, you use NetBeans or Eclipse to write your readers and writers. And apart from that, the invocation or the method calls by itself, you just code them as plain Java codes. So it's you take your normal, regular Java IDE. And you should not need any specific tooling for doing the processing of the messages by itself because it's hidden in the framework itself. So you just take your normal Java IDE, you call methods. You have to know what the method names are on the server side and what kind of parameters they take. And I'm not very, so I was working on this under the hood, so I have no clear insight on what support for application development beyond the Java IDE is there. Other questions?
What type of authentication mechanisms do you have?
What kind of applications you would use that for? Authentication. Security.
Using HTTP protocols.
We're using HTTP, or you could also use HTTPS, but. Okay, it's getting far. There is the authentication, but this is work in progress, so I cannot answer the question right now. But I mean, having this API without authentication is not good enough. But there's work going on in JSR 339, and we just have to adapt that. So we don't invent anything here anew, but we just take what is in JSR 339. Further questions? Okay, then thanks very much for your time and for your interest. I'm here for individual questions, and as I said before, if you want to know more or have a look at the API, give me a business card and we talk about it. Thanks very much.